Okay, in this video I will do this example problem, and it says consider the graph described using symbolic notation, the graph G made up of the set of vertices and the set of edges. We have 5 vertices and 1, 2, 3, 4, 5, 6 edges, and it looks like we're missing a little comma here. In any case, the first thing I notice is that the edges have curly brackets, and that means they are subsets of vertices. If an edge is made up of subsets of vertices, is a subset of the vertices, and that means that the edge is not directed. In other words, this is not an ordered pair. The B and the D don't come in any order for a subset. The second thing I notice is I have a single vertex as one of my edges, and that's going to be a loop. And so let me go ahead and draw this diagram here. I've got vertices A, B, C, D, and E. Let's see if when I arrange these vertices in this pattern I can draw it without having any overlapping edges. It says no edges crossing each other. So I have an edge from A to B, one from B to C, one from C to D, one from B to D. This looks an awful lot like the last problem. One from B to E, and one from C to itself. Okay, I did run into edges crossing each other, so I've got to unfold this diagram to complete part A. And I guess I'll just, gosh, it's an awful lot like the last problem, isn't it? A, B, C, and I'll put D up here, and E down here, and then fill in these edges from A to B, B to C, C to D, D back to B, B to E, and then C looping around to itself. And it says, what type of graph is this? Well, we don't have any multiple edges, so it's a simple graph, and it's not directed, but it does have a loop, so it's a simple graph with a loop. Okay. Is it connected? Yes. See the figure. It's obviously connected. Is it a tree? No. We have, how many cycles does this have? It only has the one, this cycle here, this triangle. So consider the cycle. To disprove that it's a tree, consider cycle D, B, C, D. That's going around this little triangle from D to B to C to D. And draw this picture of this graph after links 3, 4, and 6 have been removed. What type of graph is it now? Well, I guess we have to assume that the links are in order here. And 1, 2, 3, we're going to remove CD. Let's just redraw the thing over here. A, B, C, D, E. And we're going to keep links 1 and 2 from A to B. Let's do them in red. And from B to C. But we're going to remove links 3, 4, and 6. And now we're going to add one from B to E. And now the question is, what type of graph is it now? And this is just a simple graph with no loops, so an SG. And the interesting questions I probably should have asked here about this one are, is it a tree now? And a tree is a connected graph with no cycles, and the answer is no, because it's not connected. Okay. And it doesn't have any cycles, but to be a tree it has to be connected. Is it a forest? Yes, because D by itself is a tree because it's connected with no cycles, and the other part is connected, so yes. Okay, so I think I did that one not too bad, hopefully. So simple graph with loops was the first one. Okay, I hope that helped.